Okay, welcome back. We're on page 307 talking about the systemic versus the specific approach. Systemic, basically, I just follow step by steps. Do this, do this, do this. And then the specific is, kind of based upon your knowledge of similar scenarios, yeah, but last time we tried this and that didn't work, kind of thing. So on page 307, they have specific procedures, I assume like systemic. Check the documentation, go online and see if anyone else is having the same problem. Look for available logs in the event viewer. If something's going on, most likely it's screaming to the top of its lungs, you're just not listening. And then search the knowledge base, find out if somebody else is having the same problem, what the fix was. Do a backup, for God's sake, before you make any changes, do a backup. And then run diagnostic programs to see if it actually fixed the thing. So the tools. So from advanced boot options, we have the thing called safe mode. And in there, you have Windows repair, memory diagnostics, system information, device manager, task manager, performance monitor, So advanced boot options has some really cool things where you can boot your machine up in a diagnostic mode and learn all sorts of things about your machine. I'm not going to demo that. Okay. But it's pretty doggone cool. But by the way, we haven't really talked about this yet, but you know how in Windows you could hit F8 during the boot process and it would come up and say, oh, you want to boot into the safe mode? This is what safe mode essentially is in the server world. Okay. So there's an information technology infrastructure library, an ITIL, page 308. And basically they just come up with a list of standardized IT management practices. What a service strategy and design and transitioning from one system to another and operations and continual improvement. It's a lot of philosophy, but we cover philosophy in the other book, so I'm going to skip over that. Page 309, the event viewer. We've seen this before. I'm going to close down a bunch of this junk. Okay, so if I just go down here and just start typing event, you guys know how this works. So event viewer has tons and tons of stuff. And it's segregated out, so things that you do, custom logs, plus the machines, ones that it does, right? Okay, cool. So basically, let's talk about the types of logs. An application log. Well, this is practically anything that's associated with an application. This could be practically anything. Security, like login attempts and missed passwords, things of that nature, that'd be kind of cool to look at. Setup is like errors during the install. For example, I might see something in here. No. About me trying to install Git Update Hub and having a tough time with it. System is like disk errors and things of that nature. Those are and disk full. I love disk full, because that tells me that somebody's overdoing something on their machine. And then forwarded. So when I was doing this for a living 10 million years ago, I had an event server. So everyone not everyone. All the servers sent their logs not to themselves. Well, that's not true. They sent them to themselves and they forwarded them to this guy. And a few hot people, the director and the assistants and maybe division chiefs, the people that were high rollers. I had their stuff sent. So when I got in the morning, I would go to the event log machine and bring up the event logs, and it would have a condensed version of only those things that I was interested in. I wasn't interested in Susie's machine. Maybe I should have been. But I was interested in the boss's machine and all the servers. So that's how I did it. Okay, page 310. Understanding startup processes. In a million years ago, we had BIOS, basic input-output system, BIOS. A piece of firmware, buried deep into the motherboard, that basically allowed the machine to minimally boot. That's all it did. So it is firmware, which means I can update that stuff. But quite frankly, BIOS is not really used much now. It was too small. The amount of memory they had for it allocated and the stuff they could do was really kind of tiny. So they replaced it with UEFI, Unified Extensible Firmware Interface. Now this is a lot newer, a lot larger. Allows for things like secure boot. BIOS won't, if you just had a machine that run BIOS, you would not be able to use a secure boot thing with Microsoft. So this is all about that. So let's talk about Trusted Platform Module, TPM. So this is a security chip that's on your motherboard. Hopefully it's on your motherboard. It used to be like a discrete thing that you could buy and plug in, but that's no longer the case. And it holds security keys. So, for example, BitLocker. If I install BitLocker or enable BitLocker, by the way, I would never run BitLocker on a server. Just me. I use BitLocker on things that are portable, like a laptop. Okay, but not stationary machines. I have locks and keys and security guards. I don't need BitLocker on those guys. Anyway, so I don't. When I fire my machine up, my tablet up, I do not want to be prompted for a BitLocker password. No way in heck. So I want it stored, but it has to be stored in on the motherboard someplace. So if somebody stole my entire machine, they could probably get in. But they just stole my machine and cracked open the NVMe drive and ran off with the drive and tried to use it at home, it wouldn't work. And if you do this, you're going to have to, if you blow it, you're going to have to reinstall, Windows 11 to make it happen. A term called power on self-test, that basically happens behind the scenes. My motherboard has a little 2-digit LED that talks about, okay, we're checking RAM, we're checking this, we're checking this, checking this, checking this. And so that's pretty cool. It checks memory, it checks for devices, hunts for resource conflicts. And I have what's called a beep code. If something goes wrong, it goes beep. And look at the manufacturers, it'll tell you what the 2-digit hex code is. My machine is booting up and it stops at 20A or 2A. I go, what the heck is that? Well, I go look at the guy and it tells me, oh, well, your network card is busted or something. A master boot record, MBR. Again, it's created during the partitioning process, so you don't actually get to see it. It exists typically in the first sector of the first part of the drive. That's typically where it works. Often called the boot sector. Now, we have a thing called a boot manager, and that's a boot loader. And so when the machine fires up, it says, hey, if you only have one operating system, the function of a bootloader is to say, well, thank you for booting. Let me see which operating system you want. Oh, you only have one? Okay, fine. Here it is. So you never actually see the bootloader. But if you had a machine where you booted Linux sometimes and you booted Windows 11 the other time, then you would probably get something. There's a thing called a boot configuration data, BCD. It's a command line tool or BC edit utility that allows you to go in and tweak those things I just talked about. I'd like to add another operating system on my machine and have it prompt me when it boots up. Okay, the bootloader itself, we used that term before, but it's either NTLDR, which is the one that runs, basically Windows NT, and the boot manager guy. Again, a boot sector is typically the first sector on the disk. Boot menu on page 317. Quite frankly, that's not really normal, so I'm not normal nowadays. I'm gonna skip that. How to get to the safe mode? The old way I mentioned was, you boot your machine up, and while it's in the process of booting up, you pound on the F8 key, and it'll prompt and say, "Hey, would you like to do that?" We don't do that way. Right now, it's advanced startup options. So I'm just going to type advanced startup options. There it is. Advanced startup options. Oh, well, I'm not going to do that right now. Anyway, so the idea is that this is the guy, you can hold the shift key during a restart. You can select the troubleshooting, startup settings, and restart. It's kind of cool. So this is what it would look like if you were to boot the thing up in the advanced option. Would you like to repair your computer? Safe mode, safe for networking, enable boot loading, all those good things. Okay, on page 318, we're changing topic completely, and now we're talking about disaster recovery or disaster business continuity. So I will tell you one more time, this is of particular interest to me, so it's going to be on the quiz. I absolutely guarantee it. All right, so a disaster recovery plan, a DRP. Now this is, okay, here's basically what you need to do. You got to make an inventory of everything you got, analyze all the potential threats. Like, I don't have an ups on this guy. That'd be a potential problem, a vulnerability. Establish the organization's priority, because you can't do everything. You're insane if you think they're going to give you an unlimited budget and you'll be able to do everything. That's just dumb. Define the tolerance for in case of a disaster. So at a bank, I can afford to lose $0, right? So my tolerance for pain in a bank is really, really high. And we're going to spend money like crazy to make sure that there's no possibility that I'm going to miss a transaction. Okay. But if you're just a file server and the file server dies and they go, hey man, I can't get to my stuff. I go, yeah, wait a minute. I'll have it back up by lunchtime. So you need to know their tolerance for pain. How the disaster was handled in the past. Acknowledge that staff matters more than, oh yeah, I love that one. Because you're going to have some very sharp people doing this stuff. Execute a recovery test. Now, I did this a lot, not a lot. Probably, I don't know, once a year, maybe 6 months. I would grab like the new guy and say, okay, pretend like we're having a disaster. I want you to go to the warehouse and pull out the old server, bring it back here to the server room, plug it in, go get the install media, and reinstall the operating system from scratch. Yeah, we did that. And we took notes on what he did and what he did wrong. And he would ask, he or she would, well, where is this? And I go, well, that needs to be part of the documentation. And how do you do that? Oh, that needs to be part of the documentation. So, man, every time we did a disaster recovery drill, we added something to the documentation. By the way, you can't have electronic documentation on a disaster recovery drill. Why? Because the server that hosts the plan might be down. It's going to have to be printed. Yeah, printed plan. You can't just do it electronic in a Word document. Anyway, have management approve the guy, because typically this is going to cost money, and then update it as much as possible. All right, so before we get cranking, let me tell you, I do not like the term disaster recovery plan. When talking to management, upper management, they get the wrong idea. They'll say, well, don't we have insurance? It's like, that is not what we're talking about. Oh, the roof caved in because of a tree fell on it. Don't we have insurance for that? That's not what we're talking about. I'm talking about business continuity. So I rarely use the term disaster recovery plan. I use business continuity plan because people with a shiny new MBA can go, oh, you mean we need to still make money while this thing is down? Yes, that's exactly what we're talking about. All right, let me tell you a story. Some of you maybe even heard this story before. So this guy has a tape backup, and the tape backup is getting slow, and their data is getting huge, and it's taking like 4 hours to do a backup. So he goes to the boss and says, hey man, this is taking way too long. We need something a lot faster, because if we have a disaster, waiting 4 hours is a long time. The guy says, well, don't you do the backups in the middle of the night? And he goes, well, yeah. So who cares how long it takes to do a backup? It's like, okay, so he didn't spend the money. I asked for $5,000 for a faster tape backup, and they said, no, go away, little boy. So a disaster happens, and we have to do a restore from scratch because the entire server caught on fire. And I pull out my ancient tape backup system, and it takes 4 hours, and the boss is saying, how come it takes so long? Because I asked you for $5,000 to do it in an hour, and you told me no. See how this works? Okay. Business continuity, not disaster recovery. All right. Data redundancy obviously means stuff is stored in multiple locations. You have two servers. You got one on the West Coast, one on the East Coast, that kind of a thing. That works just great. And clustering. If you have a server that's kind of critical, you might want to have two servers there. All probably sharing the same disk space through a storage area network. Not necessarily, but it could. And so I could go in and come time to do updates. I just reboot server A. Nobody cares. It'll switch over to server B. And then I update and install new software or whatever it is on server B. Again, I can do this at random because I have two machines that are acting as a single source. And so if one of them fails, it automatically switches over. That's called clustering. So again, a poor man's way of doing this, of course, is to have like OneDrive at home. I have stuff stored on my machine, plus I have stuff on the network. Now that's not exactly the same thing, but it does accomplish, redundancy. All right, we're coming up on the 15-minute mark.